Hello and welcome to this session. My name is Udo Würz from Fujitsu.
And I'm Alex from Fujitsu.
And it's great to have you here with the session to show you something about what is a digital twin.
So Udo, we brought some very nice equipment. What are we going to talk about today?
Today we are talking about a digital twin. And you can see all the equipment that we brought with us. Mm-hmm. So it's a lot of technology that we have inside. So on one hand, we have some virtual reality.
Cool.
We come to that later. Mm-hmm. We have some augmented reality, so which means virtual world and the physical world is really joining, is really once, right? Yeah. You see everything in there. We have a robot, a device to demonstrate how you can interact with those devices from the virtual world to the physical world.
All right.
We have some technology that we need to steer all of those technologies, the robot in this example here. Mm-hmm. And we have, of course, an edge device. The edge device is needed to make sure that we can really interact. The edge device is providing all the containers that we need, providing all the trained models that we need to make sure we can interact with the robot.
And the use case that we have prepared today revolves around customer support, customer experience. So there are customers, or there might be customers who have a robot in their production, in their manufacturing. There might be also customers who don't have a robot like that, so other devices. But we will show first how to interact with the robot and take it then from there and explain how it can be utilized in other industries as well.
Yes, exactly. Yeah. Exactly. And then, of course, the question is, what is a digital twin, right? And when we are talking about a digital twin, this can be a bunch of different solutions and scenarios. So first of all, a digital twin itself is a kind of digital copy of a physical device, but also of a human as an example.
Wait, one question here. My profile in the social media, is this also a digital twin?
At the end, yes, okay. Of course, because you can create a virtual Alex out of it.
Right.
What's the behavior? What's the like? What's the dislikes? He has shopping lists, and whatever you are doing at the internet creates data, and the data is used to create a virtual Alex, so to speak. So you know everything about Alex.
Okay.
But today we are talking about a physical device where we are interacting with a virtual device, and which means from the solution point of view, when we think about companies, when you think about automotive as an example, when you have a car and the car is producing a lot of data, right? So from the engine, from the cooling system, from the streets, if you have a LiDAR system as an example, or if you have an object detection system at the car, think about self-driving cars.
Right.
And then the manufacturer of the car, they can collect all the data and then also can do some testings with the data. So you don't want to do this with a physical car. If you would like to train new behaviors, new maneuvers, or create new technology into the car. So you can really test this upfront with the digital twin, with the data you may have. And this is a great thing. And of course, you already mentioned it, support. So think about a customer who needs support. And we had a lot of issues, as you know, especially in the last year with the pandemic, but the pandemic still remains.
Right. So in the pandemic, it was not so easy to visit customers because we were all banned from traveling. We were all banned to go outside and also do the customer support in some cases. So in those cases, I think it's really relevant to have a possibility to interact with your customer very closely, not only over the phone or through video chat, but to be even closer to your customer, not physically, but in a different way. This use case gives us an idea how this could look like.
Yes, exactly. This is, I think, one of the very most and relevant topics.
Right. Or we think about scenarios where we cannot go. Let's say there is a ship traveling over an ocean, and it's far from any shore. So we cannot just simply fly there with a helicopter and do something there with our customer. So we have to interact with our customers there
Yeah.
And we also want to be close with the customers in this scenario.
Yes, and also think about systems think about cooling systems. You're cooling a stock as an example, so where you have goods in there, and in case the cooling doesn't work, all the products are gone, right? So, and you have to make sure that you can give support as soon as possible.
Right. And it's also quite cold in those cooling systems, so you don't want to go there probably. So this might be also an environment that's not really friendly. So to go there as a support agent is a challenge in some cases. I guess.
So warehouses especially. So I think this is also a really hot topic for them.
Right.
Making sure you have support when those critical elements really have an issue. Or you would like to create training videos, making sure that you have a video in place demonstrating how to disassemble and assemble a machine as an example. And with this type of technology, with virtual reality, also here the augmented reality, you can give advice to the technician how to handle this.
Cool. Yeah. And I think organizations look for possibilities to extend their customer service, to make it cool, to make it better than the customer service from other companies, from their competitors. And so they need to come up with new ideas, with new possibilities, how to serve your customer, how to extend the customer experience in a way that's not there yet.
Yeah.
So in this competitive edge can be achieved with virtual reality, augmented reality that we will show in this use case.
Yeah, absolutely. But it saves also a lot of money, right? Mm-hmm. So think about companies. And companies, they're exporting their products all over the world. They're developing their business on a global base. At the same point in time, we have a lack of staff and skills. Alone in the European Union, we have 500,000 specialists missing on the market. They are simply not available. So which means there is a lot of pressure for companies, making sure they have the right staff and skills in place. And of course, they will not have enough of them. So therefore, those types of technologies, they are really able to help them to support customers around the globe. When you're producing a machine and you deliver the machine to, let's say, Asia, thousands of miles or kilometers away, and the customer would like to readjust the machine, as an example, would like to repair it or train a new movement in case it's a kind of robot, as an example. So this is very hard because you're trying to do something with the phone or send an email or give some instructions. But here you can really go ahead and meet the customer. And this is, by the way, guys, what we will do later on, right? So you will see this, how does this work when we meet us in the virtual space and interact with the machine here on the table. Now, even if you don't have just all the specialists in place, even if you have just 5 specialists or so, wherever they are on the planet, they can go in interaction with the customer. They can support the customer. And this makes your life easier. This brings a much better service to the market, and you're much more competitive, of course.
That's really cool. I mean, you bring the skills, you bring your specialists to the customer over a long distance to the end of the world, to the other side of the world. That's really cool. You know what's also interesting? So when you think about organizations who want to extend processes, to develop new processes or extend the machines, how they are built, then this kind of technology can really bring an advantage because you can bring your specialist in front of the machine, discuss and scope the new process or the new machine with your customer a lot closer than you could do it probably through a video chat or over the phone or just through email. That's what we do today.
Exactly.
So if you do this in combination in front of the machine with your specialist, I think this is a great advantage.
Yeah. No, that's definitely true. And I think the audience will be interested what we have inside of all those technologies. And maybe we can step a little bit more into the details. I think for you guys, it's interesting to know what we have done here from a technology point of view. So let's start with the IntelliEdge.
Cool.
So IntelliEdge is an edge device. And it's, I think in English, it's ruggedized, right? That's the right term. So which means it's very robust against changes of temperature.
It has fins, right? So there's no cooler inside?
Yes, it has no cooler, which is, of course, important. You have to make sure that the device itself can handle all the different temperature environments.
Yeah.
You have a lot of interfaces, because when we are talking about the edge, we have to make sure that we can connect with each and every machine, so to speak.
Yeah, you need to connect with OT and you need to connect with IT. So you need lots of interfaces.
That's the thing.
Yeah.
Exactly. So we have Wi-Fi connectivity as well as 2 LAN ports here, which are necessary. For this topic here, we are using the LAN ports.
Right.
We have a Linux stack on top, and we are running container services, having also the trained AI models in place that we need to make sure everything is up and running.
Okay, so this is our hub for the use case, right?
That's the hub for the use case. It also provides the API to make sure that you can interact with the machine itself.
Right. So we can have this device either as a real edge device close to a machine, or we can have it as a hub like we have it in this use case, where all the information is being collected, processed, and then passed on to the lenses or whatever we are using there, right? Or to the robot.
Exactly. And what the machine is also providing is the container services that we need for the virtual reality, as well as the container service that we need for the augmented reality.
Right.
And making sure we can interact with the device. What we have done, and you said it already, we don't have all the containers here in terms of to steer the robot in terms of the technology itself. So what we have is we have a little Esprimo, which is a PC, and this Esprimo has the physical connection to this robot and is grabbing the information from the IntelliEdge, from the container services, and has a little software on board. And the software makes sure that all the control commands which were given by the intelligence are transferred via the Esprimo to the USB interface to this little computer. Maybe you can see this. This is a really small one here. And this computer controls the robot and makes sure the robot is moving in the right direction.
Okay, so hub, control unit, robot, and then we have 2 fancy devices to interact, right?
Exactly. Yeah. So what we have here is, on one hand, Oculus Quest. This is used for the virtual reality. So which means you are in the virtual room, and this is for the technician.
Yeah.
So the technician has not a robot in front of him or her. It depends. And the technician is wearing the glasses and making sure that the technician can really control what the customer is doing at the device, in this example here with a robot arm. And the augmented reality glasses, this is Microsoft HoloLens. And those glasses, they are providing a mixture of the physical world and the virtual world.
Right.
And so on one hand, you see the device itself, and you can also interact with the device. And this allows you also to project devices into a physical room.
Right. So we already featured a few possibilities of this use case. So the use case is quite straightforward. So our customer would like to talk to us. They want to interact with us. They have a case, and they call us in the virtual world, and they ask for help. And then we need to start the interaction process somehow.
Yes.
And this works with those lenses.
Yes.
So we are wearing that. A technician is wearing that, and of course the customer is wearing that. The customer has this robot in front of her or in front of him because they have an issue with this robot. They need to interact with it. They need to learn something regarding this robot. They need help with it, and that's their request. It's quite simple in this case.
Of course.
We come a bit later to more extended use cases, but this request is quite simple. So the person needs to understand, how do I interact with this robot? What do I do that this robot will move or do some activities?
Yeah, exactly. And this is exactly the use case. And with the robot, you can see that something is going on, because we would like to interact with the robot. And because we cannot place an engine from a ship into this room, right? And to see that the engine is starting or not starting if you do something in the virtual room. We have this little robot here, and then you can see when the robot is moving that we have started the movements in the virtual world or in the augmented reality world. So when we talk about the artificial intelligence that we have to make all of those here up and running, make sure that it works. Maybe it's worth to say some words about this. So we are providing trained models, as we already said, here to the system that everything can work in the expected way. How have we done this? So this solution here is very flexible. So you can train this solution here on the Primacy server, on Primacy infrastructure based on Intel technology and using SUSE FUSEML. FUSEML is a great software allowing you to do trainings with your resources that you have in the data center, as well as resources that you may have out of the data center. So a hybrid approach, so to speak, making sure if the model that you would like to train is getting more complex so that you can really bring the data to the cloud and do the training there and get it back as an example. So in our example, we have all the capabilities in our data center, as you can imagine. As a manufacturer of servers, of course, we have enough of them. And with FuseML, we are really flexible and we can choose wherever we would like to do the training. Doesn't matter, is this on the CPU, however, that we have done here? Is this done on the GPU or is this done on, I don't know, cloud or wherever? So this is very flexible and it's a great technology from SUSE to making sure that you can do the training.
Yeah, FuseML is really a nice orchestration platform for MLOps. So think about the whole process of the development. You start with a scoping process and it goes until, if you train a model for prediction, for example, until this prediction process. And over this whole process, you have so many iterations, so many teams involved, so many data sets that you have to shift from the very beginning to the very end, and you need to exchange that and redo it and do iterations and stuff like that. And MLOps helps you to so that everybody can work with the software tools they need for their work, that they can all collaborate, that they can all use the same data set.
Yeah.
It brings everything together. And this is really a nice technology that helped us a lot in this use case.
Yeah, and there's additional value if you go for the SUSE software stack. So one thing is Ranger. So the question is, once you have trained a model, how do you bring this to the edge?
Yeah.
And how do you get the data back from the edge to retrain the model to make it better? And therefore, Ranger is a great choice because then you can do a secure transfer of all the data to the core. You can do the training with FuseML and other technologies, and then bring it back to the edge and making sure that the edge is operating with the newest model and making sure you can really crunch all the numbers that you have here to do the inference part and whatever you would like to do there.
Yeah, exactly.
Should we go into the live demo?
I think we should do that now.
So let's go into the use case. So I will be the technician. I'm acting in the virtual room, and therefore I'm using the Oculus lens. And I have here some controllers. You can see it's one for the left hand and one for the right hand. I only need them for the right hand. And with this, I can start the application, which is a Fujitsu application, which is inside the device, so to speak. The device is at the end a computer where you have RAM and also flash available, and you can store all the data there. And after this, you will take the HoloLens.
Right.
And you're the customer.
I will take the HoloLens, I will be the customer, and I will be able to look through this HoloLens. I will see something on the lens. That will be what you will show.
Yes.
What you will provide as information for me. And I will be also able to look through it because I need to see the robot, because the robot will also do something.
Yes.
And this will be really cool. So I will have two images in the end, the real world and your world that you will see and provide through your lens.
Exactly. This is what we are doing. And we will do a recording of the stream for you guys so that you can really make sure that you can see everything and bring it together so that we have one picture and you see both streams at the same point in time. So let's start. Let's assume Alex is the customer and the customer needs support. And first of all, the customer is starting the HoloLens, making sure he gets really the experience of augmented reality. And this is what we are doing now. So Alex, please grab the lenses and start.
All right, so I will start the interface now. This is now in German language. Don't be bothered by that. It will go away soon. So I will start the Fujitsu app, and then I will get an interface. Take a second. Starting to activate and get the connection. All right, for now I have to choose an avatar. So I'm this avatar, nice jacket, and I will activate. So welcome, here we are. And now I see the robot arm as an icon. I see a hand, I see the tongs, I see an eye. So what I will do now is I will click on the hand. So I can activate the robot on, and now there it is. It's on my hand. So the robot virtually is standing on my hand. And if I look a bit to the right, you can see there's the physical robot in front of me as well. So now I will use my other hand, and I will just tip on this bubble, and both the virtual robot and the physical robot are moving in the same direction. I will tip at the bubble on the other side, robot is moving again, or here in front, or at the top. So I can really interact with the robot. So I'm the customer now, and I can activate the robot. I can move the robot with my hand in the virtual and in the real world. There's another icon here with the tongs, so I can also click on the tongs, and then the robot will move the tongs. It will open and close the tongs. So this is now a simple demonstration what I can do in this virtual reality in both worlds.
Yes, and now we will meet us in the virtual world. And if you guys wonder why I have looked in another direction, we have a display out there so that I can see what Alex sees with the HoloLens, and so that I get an idea what's the actual status of his view. However, I will now take on the virtual reality, the Oculus lens, and then let's meet in the virtual room.
Let's meet.
Let's meet. Hello and welcome to my house. When we look around, I think you would agree that this is really a spectacular view of a house in the middle of nowhere with beautiful northern lights, as you can see. No, just joking, because this is one of the start screens that you can select when you start the Oculus Quest. But that's not the purpose of this session. We would like to join Alex to give support for the digital twin. Therefore, I'm starting the application, and now I can give away the controller. I don't need it anymore because I have virtual hands. And now you can choose the technician who will give support to Alex. We have Jana, we have Nathan, we have Lisa, and we have Eric. And again, Jana. I select Jana. So choosing Jana. And now we will be here in the factory, as you can see here. So when I look around, you see a typical factory, so to speak. Of course, only one robot. When we look around here, you see how nice this is. And it's a very good resolution, which is needed when we give support. Now, when I look around, there's Alex. Hi, Alex.
Hi, Jana. Nice to meet you.
Nice to meet you. Can you see me, Alex?
I can see you very well, Jana.
Okay, what I'm doing?
You're waving.
Yeah, please wave back.
Hi.
Thank you. All right, so what we can see here on the table is the robot. This is the virtual robot as the virtual reality, so to speak, of the physical device. We have two knobs. One knob is to open and close the robot. At the same point in time, we can also select, we would like to move it, because I would like to show Alex some movements of the robot, and Alex can do it itself. And with the augmented reality, Alex can double check that the movement of the virtual device is in the expected way as the physical device is doing, and the other way around. Now, I select the hand, and by having the hand, I can now steer the robot, as you can see here. The robot follows my hand and is doing all the movements in the virtual reality, as well as as a physical device, and as well as the augmented reality. So maybe, Alex, you can also go ahead and move the robot.
Okay, can
in
you
your augmented reality, please?
Can you just show me a movement that I can copy?
Yes,
so that I can learn from
I would
you?
like to have it in this way, that the robot is going up.
Okay.
I will put it down, so now you have to do it by yourself.
Okay, so I will activate my virtual robot again.
Yes.
And I will do what I learned from you, like this.
Yeah.
It was a bit like that, probably more like this. And then I move it down again. Okay, thanks. That worked well.
This is one of the cases that we would like to show. It's definitely that you can give guidance to the technician how to handle the robot in the appropriate way and how to steer new movements. And of course, guys, this is, let's say, a use case or a demo case just to demonstrate how to connect virtual reality and augmented reality and physical devices, how to meet in a virtual space, and how to interact together, that you see your virtual hands doing something here. This is not a complex use case. The complex use case would be if we would disassemble the robot and showing each other where's the problem, how to fix the problem, and then assemble the robot again. But we would like to show you here what's really possible with this and how to do this.
So Udo, can you show me a more complex movement again with a few direction changes?
Okay. So up, left on this side, and then down.
Okay, I will try to copy that. So this is my robot here. I say up, a bit higher probably, up.
Right, it could be, yeah, like this. That's much better.
Left.
Yes.
A bit down.
Yeah.
And in front. Thank you. Thank you, Jana. Thank you, Udo. That was a nice tutorial. Now I know how to operate with my robot.
This is now a situation where two persons are learning from each other, right? So where the supporter sees what the customer would like to achieve and give guidance to the customer. In this example, Jana give guidance to Alex, or the virtual person of Alex. But think about a much bigger scenario where you have 10, 20 of people in a room. Maybe not this factory hall here. Maybe you would like to use a different scenario. You can define your own environment. You can, of course, program this. Maybe it's not a robot. Maybe it's an engine or a turbine or an automotive device or whatever it could be, or a circuit. Now, this is a relatively easy example, so to speak, or a simple example, but you can think about this in much more complex scenarios when we would like to disassemble the device and assemble it again. And there's also another opportunity that you can do. So because we have all of those trained models available, if I push the button here on the eyes, we can also say the robot should follow a person, or should follow a bottle, or should follow whatever the robot should do. This is the same thing what we have done here with our hands, only here with a bottle in this example. Now, this said, back to Alex. Something to add?
Thanks, Jana, for helping out. Thanks for the great tutorial. We know now how to operate our robot. And yeah, meet you next time. Nice meeting you. Bye-bye. So Udo, this was really an amazing showcase. Using this augmented reality glasses, it's insane. It was really wonderful to see what's possible there, and I think the possibilities are really unlimited.
Yeah.
let's talk a bit about the system architecture behind it.
Okay.
Did you bring something for that?
Yes, of course. And just a few slides, guys. No worries. Just to make sure it's a better understanding what's behind the scene. So I think about the use case, everything is said, where we give remote support and whatever is needed. So we can go ahead to the next slide. And this gives you more an introduction how the solution architecture will look like. So on one hand, we have those glasses. And you have to know there are different types of glasses available on the market. So we have glasses which have a GPU already implemented. And we have glasses which need GPU support by having a laptop, as an example, making sure that you can stream the video information. At the same point in time, the edge, we have seen this with the IntelliEdge, making sure we can interact with the device. Doesn't matter, is it a robot arm, is it a machine turbine, whatever you may have. And then the intelligence, which sits in the so-called microservices platform. And this is the logic behind the scene to make sure that everything is working the expected way. This is mostly done here at the IntelliEdge, making sure in all the containers that we are up and running here is the logic behind and where we can handle the data stream. So which means we have the app control, we have the virtual environment, the media, and so on and so forth. And then we can ensure that we can interact with those glasses and the platform.
Let's say you have a massive amount of data that you need for training. Where would you store that?
So we have at Fujitsu the so-called data-driven transformation strategy, and we call this DDTS platform from a physical point of view to demonstrate strategic aspects and how does that look like when it comes to data center infrastructures. And this is where we have all our resources available. This is where we have our SUSE platform available, where we have our cube flows and the MLOps and you name it, and transferring the data with Rancher to the device back and forth. And this is a very important step. And let me show you where are the challenges in this respect. So when you would like to do a training on a CPU as an example, and you put it into the memory of the server, then you have to make sure that the data itself, and it could be a huge amount of data, has to be transferred. And this is not an easy task because when you do it in the traditional way, you have some memory that has to fill up, and then you have some CPU resources making sure the calculation is done. Some customers will also use the GPU resources and whatever. And then you have to make sure that the data itself can be processed in the server itself. And when you think about transferring data in a traditional way, where you have some block devices or an NFS or whatever you may have, then it takes a long time if you have a huge amount of data that has to be handled. Now, therefore, you need a high-speed connection. And the high-speed connection ensures that you really bring the data in a very fast way to the computer and making sure that you can process the data on the SUSE platform. And this said, we are working with NetApp. NetApp is providing all the connectivity that you need to do this. And you have seen the result. It's working perfect. And we are very flexible. And you can train a huge amount of data based on SUSE, based on Intel technologies and others, and really making sure that you bring this type of use cases to life.
So what you've just explained, and when we looked at the whole life cycle of an AI project from scoping to the inference, which might be a prediction or a robot movement interaction, in this case, then what you've described is the part of training, right? So you have an amount of data and you want your robot or your system to learn from this data, to detect patterns and then to react on new information. And this detecting and reacting on new information on an edge device, that's the inference part. And this doesn't require so much compute power anymore. So the massive compute power is really needed in the first phase, in the training phase.
Yeah, in most of the cases. So in most of the cases, you're absolutely right. In some cases, when the customer has a scenario where also a lot of data is created at the edge. Think about automotive. When we think about cars and the cars are creating data, you would like to optimize the cars also with respect to self-driving vehicles and so on. This is where you have to handle a massive amount of data also at the edge. But in most of the cases, industrial sector, manufacturing, transport, Yes, you're absolutely right.
Great. Thanks a lot for the explanation.
Thank you.
Thank you. Thank you very much for joining, for listening to our use case presentation. We hope you liked it. So the case itself, the explanations around it, the possibilities that we see with this kind of use case in different industries. And yeah, hope to see you soon in more discussions with this technology, with those cases. Take good care and see you soon. Bye.
Thank you. Bye-bye.